For most of the year, the Gulf of Mexico is teeming with marine life, from tiny crustaceans to massive baleen whales. But every summer, disaster strikes. Around May, animals begin to flee the area, and soon, creatures that can't swim or can't swim fast enough begin to suffocate and die off in massive numbers. From late spring to early autumn, thousands of square kilometers along the coast become a marine dead zone, unable to support most forms of aquatic life. This strange annual curse isn't unique. Dead zones like this one have formed all over the world. But to explore what's creating these lethal conditions, we first need to understand how a healthy marine ecosystem functions. In any body of water that receives sufficient sunlight, plant-like organisms such as algae and cyanobacteria thrive. Clouds of algae streak the surface of deep waters, and in shallower regions, large seaweeds and seagrass cover the ground. Not only do these organisms form the foundation of local food chains, their photosynthesis provides the oxygen necessary for aquatic animals to survive. Besides sunlight and CO2, algae growth also depends on nutrients like phosphorus and nitrogen. While such resources are typically in short supply, sometimes a surrounding watershed can flood coastal waters with these nutrients. For example, a large rainstorm might wash nutrient-rich sediment from a forest into a lake. These additional resources lead to a massive increase in algae growth, known as eutrophication. But rather than providing more food and oxygen, this surge of growth has deadly consequences. As more algae grows on the surface, it blocks sunlight to the plants below. These light-deprived plants die off and decompose in a process which uses up the water's already depleted oxygen supply. Over time, this can reduce the oxygen content to less than 2 milligrams of oxygen per liter, creating an uninhabitable dead zone. There are rare bodies of water that rely on natural eutrophication. Regions like the Bay of Bengal are full of bottom-dwelling marine life that has adapted to low oxygen conditions. But human activity has made eutrophication a regular and widespread occurrence. Nutrient-rich waste from our sewage systems and industrial processes often end up in lakes, estuaries, and coastal waters. And the Gulf of Mexico is one of the largest dumping zones on Earth for one particular pollutant, fertilizer. American agriculture relies heavily on nitrogen and phosphate-based fertilizers. 31 states, including America's top agricultural producers, are connected to the Mississippi River Basin, and all of their runoff drains into the Gulf of Mexico. Farmers apply most of this fertilizer during the spring planting season, so the nutrient flood occurs shortly after. In the Gulf, decomposing algae sinks into the band of cold salt water near the seafloor. Since these dense lower waters don't mix with the warmer fresh water above, it can take 4 months for tropical storms to fully circulate oxygenated water back into the Gulf. This dead zone currently costs U.S. seafood and tourism industries as much as $82 million a year, and that cost will only increase as the dead zone gets bigger. On average, the Gulf dead zone is roughly 15,000 square kilometers, but in 2019, it grew to over 22,000 square kilometers, approximately the size of New Jersey. Human activity is similarly responsible for growing dead zones around the world. So what can be done? In the short term, countries can set tighter regulations on industrial runoff and ban the dumping of untreated sewage into ocean waters. On farms, we can plant buffer zones composed of trees and shrubs to absorb runoff. However, long-term solutions will require radical changes to the way we grow food. Farmers are currently incentivized to use techniques that reduce the health of the soil and rely heavily on nitrogen-rich fertilizers. But there will be less need for these chemicals if we restore the soil's natural nutrients by planting diverse crops that manage soil erosion and fertility. Hopefully, we can make these fundamental changes soon, because if we don't, the future of our marine ecosystems may be dead in the water. Fish need our help. By 2050, there will be more plastic and trash in the ocean than fish. Could the Earth really run out of fish? Find out more about the serious threat of overfishing and what we can do to prevent it with this video.